Okay, this is going to be a quick little run through of the momentum and collision test. One, in case anyone is planning on retaking it. Um, so you just have that same general idea of how to do this. I'm not going to go over any of the normal questions because, frankly, we already went over those. So again, I'm not just like I did with the final. I'm not actually going to give you guys the answers here. Rather, what I'm going to be doing is showing you how to do them, showing some of the common mistakes that people made, and kind of going from there. Okay. So Andy kicks a stationary 550 gram football with an impulse of 4.4 kilogram meters per second. If the kick lasts 0.25 seconds, what is the resulting acceleration? Okay, so we know that impulse is force times time. Okay, so we're looking for acceleration. So I'm just going to kind of go acceleration. We're going to need to use Newton's second law and go force divided by mass. To find force, we're going to go force equals impulse over time. So to go 0.550, why 0.550? Because we need it in kilograms. Divide that by, that's kilogram meters, sorry, impulse. I'm getting ahead of myself here. Impulse, it said 4.4 kilogram meters per second. Time is 0.25 seconds. So that when we divide that out, that's going to give us the force applied. We're then going to take that force that we just found and divide it by 0.550, and that's going to give us our acceleration. Andy and Angie are playing sprouts. Think marbles, but with perfectly round Brussels sprouts. Two sprouts are rolling directly north. So think of this like a car collision where one car rear ends another car. They're both going to end up going north. So this is a 10-gram sprout. So I'm going to put that at point. So a lot of this was not realizing that I gave you one mass in grams and one in kilograms. Okay, so I'm going to go 0.010 kilograms and 0.025 kilograms. Okay. Actually, I got those backwards. This is 0.010. This is 0.025. Okay, one's 10 grams, the other one's 25 grams. We switch them to kilograms. This one's moving forward, and again, I gave you centimeters per second. I'm going to change that, but notice my answers are in meters per second, okay, or centimeters per second. But here's the thing. Like, guys, look at this. They're both traveling north, right? They bump into each other, so they're both going to continue traveling north, assuming that we have, well, let's see what happens. Maybe it bounces off and travels the other way. That could happen. So this is at, we got 0.15 meters per second, and this is at 0.2 meters per second. So this is an inelastic collision, or an elastic collision, perfectly elastic. So we're going to use our MAVAI plus MBVBI equals M sub A V sub A sub F plus M sub B V sub B sub F. So this is going to be 0.01 times 0.15 plus 0.025 times 0.2 equals 0.01 times 22.1 plus 0.025 times x. And this is what we're looking for, that final velocity there. 0.01 times 0.15 equals so that's 0.0015 plus 0.025 times 0.2, 0.005 equals 0.221. 0.221 times 0.01 equals, that's 0.00221 plus 0.02x. So I'm going to add up 0.005 plus 0.0015, and I get 0.0065 equals 0.00221 plus 0.02x. I'm going to subtract this 0.00221 from both sides, minus 0.00221. And I get 0.00429 equals 0.02x. And I must have done something wrong because my answer's not there. I get 0.2145 meters per second to the north, which is not the right answer. So 0.001 times, let me go double check my math. Oh, it's 0.00015. Plus 0.005. No, that's right, 0.0015 plus 0.005, 0065. Okay, because I forgot to bring my 5 down. It's 0.025. And what we end up with is 0.01716. So that's going to be, or sorry, 0.1716. Okay. So that's going to be 0.172 north. Okay. Angie is skating holding a 0.15 kilogram snowball. She's Andy lacing his skates and takes her shot. So this is probably hands down the most difficult problem that I don't think anyone even understood. So here's what happens. She's skating holding a snowball, right? So her mass, so this is a momentum problem. We have two objects. We have her mass and her velocity plus the snowball's mass and the snowball's velocity. And that equals the sum of their final momentums. Okay, so a lot of you guys looked at this as kind of like a reverse inelastic collision, which is kind of an interesting way to look at it, like a good way. Like I love the ingenuity that you guys showed on this. This is how it's done. We have her skating along at 2.5 meters per second, right? She's carrying the snowball. So the snowball is also skating along at 2.5 meters per second. She throws the snowball. We don't know how fast she's going. But the snowball is now going 32 meters per second. So this is the equation that you guys need. That was not pretty. Sorry about that. This is the equation that you guys need to solve for that. Okay. Andy's in the middle of a cabbage heist and pushing a 13.7 kilogram cart at 6.25 meters per second to the right when he runs into a 12.4 kilogram cart moving at 7 meters per second to the left. How much kinetic energy is lost? So here's let me show you kind of the way this is done, right? So we have m sub a v sub a sub I plus m sub b v sub b sub I equals m sub a plus m sub b times v sub f. And most people were able to figure out that this is the equation we need to find our final velocity. The problem that I would say 99% of you guys had was when you were putting this together, you forgot to account for the fact that they were moving in different directions. So instead of ending up subtracting these two numbers right here because of that -7, you ended up adding those two numbers. So instead of the final velocity being kind of a less than 1 type thing, you have the final velocity being, I think it was like 6.6 or something like that, or 5.6, depending on which period you were in, because I switched the numbers around for each period. But what you should end up with, 13.7 times 6.25. So if this is 85.63 plus a -86.8, okay, equals 26.1 v sub f. So notice here, if we go 86.8 minus 85.63, we end up with -1.17. So we're moving to the left. So Andy slams his cart into this other cart and ends up getting pushed back because the other cart has more momentum. Specifically, his final velocity would be 0.045 meters per second to the left. Okay. So then when you're sitting in there and you're looking at the kinetic energy lost, this is going to be your final velocity. Hold on, let me go let my dogs in. I say dogs. It was just the one. It was just Rama. My other dog was sleeping on the couch currently, so because you care. Anyway, okay, and this was a toughie too. So all 75 kilograms of Angie's spacesuit and gear is floating outside of her spaceship. So here's Angie. She's going, woo, floaty, floaty. Here's her spaceship. We had some really good spaceship drawings. This is not one of them. Okay, that looks like, I don't know. There we go. That's her spaceship. Okay. Someone drew like an alien with a flying saucer. It was awesome. So she turned around and checking her suit, and before she knows it, she's now 35 meters away. So what she does is she takes this wrench and she throws it this way. So 2 kilogram wrench, and she throws it that way at 20 meters per second. Well, as she's floating, so here she has a 65 kilograms, or 75 kilograms, right? So watch what's going to happen then. We're going to have mass A, which is V sub A sub I, plus mass B, V sub B sub I, equals mass A, V sub A sub F, plus mass B, V sub B sub F, right? So we have Angie, 75 kilograms. Actually, we have Angie at 73 kilograms because when she's starting off, that 75 kilograms includes the 2 kilogram wrench. So if we're starting to view the wrench as a separate object, we need to subtract it from her mass. Okay, 73 plus 2 equals, so that's 0 and 0, right? And that makes sense because when they start off, they're just kind of floating in space, nothing doing. And that's going to give us, then we have 73 kilograms. And we don't know what her final velocity is, right? That's what. Plus, we then know that the 2 kilogram wrench is going at, we're moving to the left in this picture, so we're going to call it 20 meters per second. So what we're going to do is we're going to use this to find her final velocity. We're then going to use the fact that we know that time equals displacement divided by velocity. So we know that here, at least 35, we're going to divide that 35 meters, because that's how far she needs to go, by her velocity. And that's going to tell us how long it's going to take her to get there. So if you watch this video, you watch the final review video, again, please understand the final review video is not a question for question mimic of the final, even though there are questions on there that are similar to what's going to be on the final. Rather, some of those questions have multiple skills involved that you are going to need to use individually on the final. Every question on the final review would be a 5-point question, because a lot of times you have to do 2, 3, 4 things. And if you take one of those things by itself, that's a 3-point question. So hopefully that helps. Hopefully this helps. Hopefully you understand things a little bit better. And have a wonderful evening.